Okay, linear quadratic systems of equations. So we're doing a little more systems again this time. It's just we're throwing the quadratic piece into it since we did not use those in the first time that we did them back with our functions. So, a little overview here. So different ways that we can solve is by using the substitution method. So you can substitute, well, Belky, pay attention to grammar. Substitute one of the equations for one of its variables. So you're going to rearrange an equation so you have a y equals or an x equals, and then you're going to plug whatever equals into the other equation. So then you're going to plug the expression from the first step into the other equation in order to solve for the variable. And then plug the answer that you get from the second step into one of the original equations and finish solving. So we're just using a substitution method for this one. There's really no elimination method that you can use because a linear has the largest exponent of 1. A quadratic has exponents of 2. So there's really no way to be able to eliminate since they don't have the same degrees. Again, quadratic is your degree of 2. Degree 2, and a linear is a degree of 1. So you can't use elimination method. You have to do substitution method, or you can graph them. So when we are graphing, you can either end up with two solutions. So picture kind of like this, where your line goes straight through your parabola, or it could be a circle, and you could have two solutions. You could end up with one solution, or you could have no solution. Those are really your only options this time around. You're not going to get infinitely many because, again, you have a linear and a quadratic. There's no way that they're going to be the same, making every single point a solution to it. So we're just going to have two solutions, one solution, or no solution for these problems. So let's take a look at it algebraically. So here's our first example. We want to solve algebraically the system below. Keeping in mind, again, we can either have two, one, or no solutions. So I'm going to take this, and I'm going to plug it into there. So we get 2x minus 4 equals x squared minus 4x plus 1. So again, substitution. You're just taking that, substituting in for y, and now we're going to do our favorite thing, algebra, to solve. So I'm going to subtract my 2x and add my 4 over so that I have everything on one side, my 0 on the other side. So now my quadratic is in standard form. So if I factor, I get x minus 5 times x minus 1. Set them both equal to 0, and I end up with 5 and 1 as my x values. So then I'm going to plug those in to be able to get my corresponding y values. So I'm going to use my first equation there to get my y value because I think that's going to be a little bit easier to use. So that's going to be 2 times 5 minus 4, so that's 10 minus 4 gives us a 6. Here I'm going to plug in a 1. 2 minus 4 gives us a negative 2. So 5, 6. And 1, negative 2 are our final answers for that one. All right, let's try another one. So again, I'm going to take this stuff, plug it in for that y down there. Equals negative x squared minus 4x plus 5. Now this time I'm going to do it a little bit differently because what I'm actually going to do is I'm going to take this stuff on the right side here, and I'm going to bring that over to the left because I can't factor with a negative x squared. So I don't want that to stay negative. So I'm going to do add my x squared over, add my 4, subtract my 5, and that actually makes my 5s cancel out altogether. So then I have a nice GCF factor here to factor out an x. So we get x equals 0. And x equals negative 3. So So again, I'm going to go ahead and plug into an equation. Doesn't matter which equation, you will still get the same answer for y. So I'm going to plug into that first linear equation just because I think it's going to be a little easier. So I get y equals 5, y equals 3 plus 5, so y equals 8. So 0, 5, negative 3, 8. Those are our two solutions for this. All right. Let's take a look at our graphing. So we're going to solve these ones by graphing here. If you don't have your calculator, grab it. You're going to want it, especially to help us with graphing those parabolas. Sometimes it's just helpful. So negative 2x minus 3, that is my linear. So I'm going to go ahead and graph that one. That's going to start at negative 3, down 2 to the right 1, and then I'll have to work backwards. I always like to get as many points as I possibly can to draw my lines. There we go. Especially make sure you label it, because if you have more than one thing on a graph, like here we will, you definitely want to make sure you are labeling. So then I'm going to get a table here. I'm going to go from negative 4 to 2. Remember, use that calculator to help you with your table if you need to. That's where I got these numbers from. I used my calculator to help me. So I'm going to plot mine. I obviously can't plot negative 4, 13 because my graph doesn't go up to 13. So I'm going to go with negative 3, 3, negative 2, negative 3, negative 5, negative 3, and positive 3. So I can see I have two solutions. There's two spots where my graphs intersect. So one of them is at the point negative 3, 3, and the other one is my y-intercept at 0, negative 3. Make sure you state your solutions once you've drawn the graph, because I can't tell you how many times I've seen kids draw these beautiful graphs and they look fantastic, but then they don't actually finish the problem and they don't state the solutions. All right, let's take a look at the next one. So again, I have another line. Start at 4, negative 1/2, so down 1 to the right 2, down 1 to the right 2, down 1 to the right 2, up 1 to the right 2, up 1 to the right 2. Y equals negative 1/2 x plus 4. So there is my line. Now I'm going to draw in my parabola. I'm going to use my table. Negative 4 to 2 again. Negative 2, 0, 1, 2. Negative 6, negative 1, 2, 2. Negative 1, negative 6. All right. 1, 2, 3, 4, 1, 2, 6. 2, negative 1, 3. So once you get your points, plot them. And that's what our graph ends up looking like. So this one has no solutions, because our two graphs don't cross. My line never crosses my parabola there. All right, so we're going to do one more. Go pause the video, grab your notebook if you don't already have your notebook with you. All right, we're going to do one more on that next page there. So our directions are find all solutions to the following system, both graphically and algebraically. So we have to do both. We have to graph it and we have to actually do our algebra work for this graph, or for this problem. So this time it's going to be a circle. So x minus 2 squared plus y plus 3 squared equals 4. And then we have a line. So here's our system. So we're going to find all solutions to the following system, both graphically and algebraically. So I am going to, normally I would give you the grid, but this one I'm just going to quickly sketch one. Try to keep your little tick marks there as symmetrical as possible. All right, so again, we have a circle here, x minus 2 squared plus y plus 3 squared equals 4. So for my circle, we have a center at 2, negative 3. So I'm going to plot that to negative 3. And then our radius here is a 2. So I'm going to go up 2, to the right 2, to the left 2, and down 2. I'm going to draw the best circle I can possibly draw by hand. And I label it, because you should always label it. So then I am going to rearrange my linear equation so that it's in y equals, and then I can graph it. So I'm going to subtract my x over, divide by negative 1. And I have the line y equals x minus 3. So I start down 3, up 1 over 1, up 1 over 1. Yeah, up 1 over 1. Again, my lines are off just a little bit. So based on the graph, I find that we have two solutions here. We have a solution at 0, negative 3, and we have one at 2, negative 1. So hopefully we will find that that's also what we have when we do it algebraically. So algebraically, we still want to do substitution. So I'm going to take my linear equation that I rearranged, my x minus 3, and I'm going to plug that in for the y of the circle. So really the same steps that we were just doing when we had just a parabola. That's going to give me x minus 3 plus 3 squared. Because again, x minus 3 was what I plugged in, and then there was a plus 3 already in those parentheses, but x minus 3 and x plus 3, those 3's are going to cancel. So x minus 2, squaring that gives me x squared minus 4x plus 4 plus x squared equals a 4. So again, I multiplied this out. Remember, it's x minus 2 times x minus 2, which is why I ended up with a trinomial here. So then combining my like terms, so that's going to give me a 2x squared minus 4x. And I'm going to bring over that other 4. So it's really going to cancel my 4's. And then I got a GCF factor of 2x. X minus 2 equals 0. So I get a 0 and a 2 for my x's, which means we're doing it pretty well because that's what we had for the x's from our 2 points. And then I'm going to plug those in. Again, I'm using that same linear equation that I had up above. So I get -3 and -1, and my answers match what I had graphically. That means we did it correctly. But this is the kind of question that they ask a lot of times on that Regents exam, is for you to do both algebraically and graphically. So if they ask for that, you got to make sure you do both parts, and your answers absolutely should match. If they don't, go check yourself.